Hello everyone, welcome back to White Collar. Today in this video, we are going to see what are the causes to change the physical state of matter and how it is done. Before getting into the video, a sub to the channel would mean a lot, and of course, hit the like button and share this with your friends and family. Alright, without any further ado, let's get started. Before going into causes for change in physical state of the matter, let's have a look at common temperatures in various temperature scales, which are the most commonly known and used temperature scales such as Kelvin, Celsius, and Fahrenheit. The absolute zero is based on the Kelvin scale, and the rest, such as room temperature, melting and boiling points of water, are commonly calculated on the Celsius scale. For comparison, we are going to see the Fahrenheit scale also. Now, what causes the change in physical state of the matter? The state or phase of a given set of matter can change depending upon the temperature and pressure conditions, etc. Let's just take the two basic states of matter, solid and liquid. If you increase the temperature, the solid is going to melt down to form liquid. This process is called melting, and the point where the solid starts to melt is called melting point of the substance. Now, let's just add the third state of matter, which is gas. If you increase the temperature furthermore, the liquid is going to be converted into a gaseous state, and this process of conversion from liquid to gas is called vaporization. The point at which the liquid boils is called boiling point of the liquid. What happens if we decrease the temperature? If we decrease the temperature, the gas will undergo condensation to form liquid. The point at which gas turns into liquid is actually called dew point. If we decrease the temperature furthermore, the liquid is going to be converted into solid, due to freezing. The point at which the liquid starts to freeze is called freezing point of the liquid. Would it be possible to directly convert solid into gas? Yes, we can make it. In some particular substances, if we increase the temperature, the solid would actually get converted into gas, without undergoing the liquid state. This process of solid turning into gas, without reaching the liquid phase, is called sublimation. In reverse, that is, if we decrease the temperature, it's going to be the vice versa. The gaseous state won't turn into the liquid. Instead, it will directly get converted into solid. This process is called deposition. Now, can we link these three basic states of matter with the other artificial states of matter? Yes, we can. If we increase the temperature furthermore in the gaseous state, it will eventually reach the state called plasma. This process is called ionization, simply because of the fact that plasma is actually an ionized gas. And if we decrease the temperature from plasma, it will go back to the gaseous state, and this process is called deionization. We are now moving on to the second part of this video. What is latent heat? The heat energy which is used to break the force of attraction between the particles of matter is known as latent heat. Since this heat is hidden, it is called latent heat. It is of two types, latent heat of fusion and latent heat of vaporization. The amount of heat energy required to change 1 kilogram of a solid into liquid at atmospheric pressure at its melting point is known as latent heat of fusion, and the amount of heat energy required to change 1 kilogram of a liquid into gas at atmospheric pressure is known as latent heat of vaporization. Coming back to liquid gets converted into gas, we can do this basically by two ways. One is boiling and the other is evaporation. Now, the million-dollar question is, if it both gets the job done, then what is the difference between them? We are just going to discuss it. Boiling takes place only in liquids, but evaporation takes place in both solids and liquids, since some solids can also get into gaseous state. Boiling occurs in a specific temperature, that is, at its boiling point temperature. On the other hand, evaporation can occur in any temperature. Boiling requires high amount of heat and constant temperature, but not in the case of evaporation. It doesn't require any external heat and can occur in any pressure. Usually boiling takes place at the temperature more than the temperature at which the evaporation occurs. Boiling takes place from whole liquid mass, but the evaporation happens only at the surface level of the liquid. Boiling is a speed and rapid process, and evaporation is slow and steady process. The vapor pressure is equal to the atmospheric pressure in case of boiling, but it is not equal to atmospheric pressure in evaporation. In fact, the vapor pressure is less than atmospheric pressure. Boiling forms bubbles, and evaporation doesn't. Speaking of evaporation, we have to see what are the main factors affecting the evaporation. There are 4 major factors, starting from increase in surface area, in which, the bigger the surface area is, the better and sooner the evaporation takes place. So, it actually increases the evaporation. Secondly, increase in temperature obviously increases the evaporation, since the kinetic energy of the particles increases. Third one is increase in humidity. Now, if there is an increase in humidity, that is, the amount of water content in air, then it's not going to help the evaporation, so it decreases. Last but not least, increase in wind speed. Here, the water vapors are blown away by the fast-moving wind, making room for further more evaporation to take place. With this, we are winding up this session about the physical change in matter. From next video on, we are going to see the chemical classification of the matter, so keep on with the channel for very next awesome videos. See you guys in the next one. Until then, signing off.